So in our example 2 of geometrical ratio, the aspect of similarity, we are given this diagram. And what we have to find is this NR. We want to establish that two triangles are similar here. I told us in the previous example that for two triangles to be similar, they must have their corresponding angles equal. And the condition is what we call AAA. AAA, angle, angle, angle. So how do we ascertain that? Let us look at it. We have the triangle PMN, and we have triangle PQR. Here, we are not giving things like additional information we are giving in example 1 where we have parallel lines that will enable us to establish that two angles are equal, whether by alternate or corresponding. We are not giving that. And we need to show that there are 3 corresponding angles are equal before we can conclude that the two triangles are similar. How do we establish that? Thank God the examiner already gave us a number of angles here. First of all, if you look at in the smaller triangle, we have angle P. B equals to angle P being equals to angle P. Both the two triangles share P. If you look at it, the two triangles share P. Then, if you look at M in the smaller triangle equals to R in the bigger triangle, M here, angle M in the smaller triangle equals to angle M in the smaller triangle. It's same thing as R in the bigger triangle. So we have angle P in the smaller equals to P. Both of them share the angle. Because if you mention their name, if you say triangle PMN and the second triangle PQR, both of them have P. So that means they share the angle there. M in the smaller triangle is given to be equals to R in the bigger triangle. And also N, look at it, a single marked arc equals to this Q. N in the smaller triangle equals to Q in the bigger triangle. We can now use this equality of angles to arrange the lettering of the triangle. So to have the lettering here, that is triangle PM, we can now conclude that triangle PMN is similar to triangle in that order too, PRQ. And since the two triangles are similar, the ratio of their corresponding sides too will be the same. That means if you pick PM here, it will be PR here. If you say PM here, ratio PR equals to, choose another side here, we can choose MN. MN ratio RQ equals to, which side are we here to choose? A PN. Side PN ratio PQ in the second one. So just choose it. If you choose first two letter, to be first two letter here. The second and third, second and third. First and third, first and third. So the ratio, we have this equation now. You go back to the diagram, substitute available values or the given values. What is PM? Are we giving? Yes, that is 3 over PR. Do we know PR? What's PR? P to R is 5 plus NR. Or PN is 5. NR is not known. That's what we have to find. That is 5 plus NR. 5 plus NR equals to, are we giving MN? MN is not giving. Are we giving RQ? RQ is not giving. What about Pn? I will give you on the diagram Pn, that is 5 over PQ. Where is PQ here? PQ is 3 plus 7, that is 10. So we equate the first and the last ratio because the one here, both numerator and denominator are not given. So we simply have, 3 over 5 plus NR equals to 5 over 10. 5 over 10, if you like, you can reduce it as 1 over 2. If you like, you can still leave it. Cross multiply. 5 multiply, this one will multiply this. So we have 5 multiplying 5 plus NR. 5 to multiply 5 plus NR equals to 3 to multiply 10, that is 30. We open the brackets to have 25 plus 5 NR equals to 30. Move 25 to the other side in the form of collecting like terms. 5 NR equals to 30 minus 25, that is 5. Then you can now divide both sides by coefficients here, this 5, to get NR. Therefore, NR equals to 5 divided by 5, which is 1 centimeter. And that's the value of NR that we have to find here. From there, we move on to example 3.